There were a lot of comments in our recent video asking about our support settings after our supports came off so easily and satisfying on this Primaris helmet. Now I'm going to let you in on a little secret. It's not just the slicer settings. Now let's talk about it. If you want nice clean prints, you have to make sure that your printer is tuned properly. There are many things that you can tweak and dial in on your 3D printer, but we're just going to go over the basics here. This routine applies mostly to any 3D printer, can be replicated over and over again easily, and only takes about 10 minutes minus some short print times. So let's walk through our typical tuning process and what setting to change in our slicer. First, you're going to want to install Pronterface, a program that allows you to control your 3D printer from your computer via USB cable. Connect your computer to your printer and run Pronterface. Looking at the top left of the page, you'll see port and 2 drop-down arrows. You want to select COM3 and 115200 and then click Connect. It should say printer is now online. This means you have control of your printer through Pronterface on your computer. Now, if you haven't already, feed some filament into your printer and set your calipers to 120 millimeters. Measure out from the end of the tube feeding into your extruder. Make a noticeable mark as you'll need to see where that mark ends up later. Now, back to the computer. Set your temperature. We usually go with 230 here and let the nozzle heat up. While that's heating up, let's check what the current settings are by sending an M503 command. This just retrieves the current settings for the printer. We're going to be calibrating the E-steps here, so scroll up and find the M92 line and look at the number after E. Those are your current E-steps. Take note of this number as you'll need it later. All right, whoa. Slow down. What are E-steps? Well, basically, it's the number of steps your motor takes to extrude 1 millimeter of filament. If your E-steps are not calibrated correctly, you could be over or under extruding, resulting in unwanted artifacts or holes in your print. Once we dial that in, you should get better quality and proper extrusion throughout your print. Okay, we can see the nozzle is heated up by looking at this graph, or we can look at the target and current temperatures listed here at the bottom. Go ahead and extrude 100 millimeters of filament and go back to the printer, keeping an eye on the mark we made earlier. And when that's done extruding, go ahead and measure from the tube back to where your mark is. We are left with 25.89, so we'll go ahead and round up to 26. Since we measured and marked 120 millimeters of filament, but only extruded 100 millimeters, we subtract that 20 millimeters from our 26 millimeters, leaving us with 6 millimeters left over. That means even though we told the printer to extrude 100 millimeters, we really extruded 94 millimeters, 100 minus 6. So why did we measure 120 millimeters if we're just going to subtract it anyway? Well, we add that 20 millimeter buffer zone just in case our E-steps are too high and it extrudes over 100 millimeters. In that case, it would end up in the tube and you would not be able to get a measurement. That's why we use a little buffer zone of 20 millimeters. Then to the math. Luckily, it's super easy, don't worry. We take our expected extrusion distance of 100 millimeters and we divide it by our actual extrusion distance of 94 millimeters. Multiply that by your current E-steps and you're left with your new E-steps. In our case, it's 430.85, so we'll round up to 431. Now we'll change the printer settings by sending an M92 E431 command, with that E number being the number you calculated. Then we send an M500, which is just a save command, and then another M503 just to check. Find the M92 line again and check the E-step number to make sure it changed. Then we'll go back to the printer, mark 120 millimeters of filament again, and extrude another 100 millimeters, the same as before. Once that is done, measure again, and you should have 20 millimeters left over. If you're not quite there, repeat the process until you're satisfied. If you're way off, make sure that you type the right number into the E-steps and that your math is correct. Once that's done, your E-steps are calibrated and you're done with Pronterface. Go ahead and click disconnect and unplug the printer from your computer. Step 2 is calibrating the flow rate in our slicer settings. This is even easier, but takes a little bit more time since we're actually printing something. For this, you want to print a small hollow square with walls double the thickness of your nozzle. We are using a 0.4 millimeter nozzle, so we are printing a square with 0.8 millimeter walls. It's a super easy model to make if you know any CAD, but we'll put a link for easy download in the description. In slicing this model, you should make sure your flow rate is set to 100% in your slicer, and then you can slice and print. Wait for that to finish, and then we're going to use our calipers again to measure the wall thickness. Measure every side multiple times if need be, and get an average thickness. In our case, it was pretty high at 0.9. Back to the calculator. We have another simple formula. Take your expected wall thickness of 0.8 and divide by the actual printed wall thickness of 0.9, which gives us 0.89. Move your decimal 2 places to the right to get a percentage, giving us 89%. So we set our flow rate to 89%, slice, and run the print again. When that finishes, we'll measure again and make sure we've got our flow rate correct. Save your profile settings, and you're done. Obviously, there are more changes we can make and settings we can change if you want to put the time into it. And we may do a video in the future going more in depth into those. This is just a quick tuning guide that anyone with a 3D printer can follow and finish in about 30 minutes, and it makes a tremendous difference in your print quality. Thanks for watching, and make sure to subscribe if you want more 3D printing tutorials and content. We've got a lot of projects coming up, and we cannot wait to share them with you.